Let's prove this identity. The right-hand side is not easy to separate at all, but the left-hand side, we can expand the bracket and then try to simplify it. So I'm going to start with that. Now we have a double bracket here, cot theta plus cosec theta all squared. So basically I'm timesing it by itself. So it's going to become cot squared theta plus 2 cot theta cosec theta plus cosec squared theta. Now, in the answer, they've got it as like normal trig functions rather than reciprocal ones. So at this point, I'm going to write them in terms of sine and cos and so on. So tan is sine over cos, cot is cos over sine, and then I'm going to be squaring it. So cos squared theta over sine squared theta. And then cosec is 1 over sine. So we can see we've got a common denominator. Right, I can combine these. So I'm going to get cos squared theta plus 2 cos theta plus 1 all over sine squared theta. Just got to roll with it and hopefully, it will work out. So at this point, right, now in the final answer, we've only got cos. So I could replace sine by 1 minus cos squared. And it's a case of thinking, how can we simplify this? And there's going to have to be some cancelling down for it to simplify. And in fact, we can factorize both the top and the bottom. So the top becomes cos theta plus 1 all squared. And the bottom is a difference of 2 squares, so it's 1 minus cos theta times 1 plus cos theta. So this cancels with 2, and we're basically done. Just going to write it as 1 plus cos theta over 1 minus cos theta. So started with the left-hand side, obtained the right-hand side, we're done. Second part is then saying hence solve this equation. So that means use part A to help you, and also remember we're working in radians. Okay, now we've just shown that this whole thing is 1 plus cos theta over 1 minus cos theta. So using part A, we're going to get 3 times this. Is 2 sec theta. I'm going to write that as 2 over cos theta. Get it all in terms of cos theta. So then 3 times 1 plus cos theta is going to be 2 times 1 minus cos theta over cos theta. Just realized I should have cross multiplied as I was going. Basically times both sides by cos theta and both sides by 1 minus cos theta. So the cos theta that I was divided by is now going to end up on the left-hand side. So hopefully you're okay with that. And we have what is a hidden quadratic trig version. So let's expand it. We're going to get 3 cos theta plus 3 cos squared theta is going to be 2 minus 2 cos theta. Tidy this up. Now you've got two options at this point. You can either do a substitution for cos theta, or you can factorize directly in terms of cos theta. So if it's going to factorize, it's got to be 3 and just cos theta, and then we just have to put in 2 and 1 somehow. So if I make that 2 and make this plus, I'm going to get plus 6, and make this one minus 1. That will all check out. Cos theta is going to be a third or minus 2. Straight away I can reject this one. It's a solution to the quadratic, but not to the trig equation, because the minimum value of cos is minus 1. If you put it in your calculator, inverse cos of minus 2, you're going to get math error. So theta is going to be inverse cos of a third, which is 1.2309. Just get my cos graph drawn. So we have just found this value here on the cos graph, but we also want that one because we're solving between 0 and 2 pi. This here is 2 pi at the very end, it's equivalent to 360 degrees. So my other solution is going to be 2 pi minus 1.2309. Gives 5.052. Okay, there we have it.